without factor. Anyway, okay, so right now we answered two questions. The first one, what is the thickness? The second one, what is the dimension of footing? We need to answer the third question, how much is steel reinforcement? To design your steel reinforcement, I would like to draw this isometric. We have this footing, and we have this core. That's right. We have concentrated load. This time it will be P ultimate. This column is supported by this foundation or this footing by soil. So if you apply concentrated load, I expect pressure from the soil. On the area of your footing. So the surface of footing, the contact surface between footing and soil, we have pressure trying to support the applied force. Do you agree? Do you agree? So I converted one concentrated load at one point to surface load on the soil. So I can expect the soil will react by pressure called Q ultimate. This Q ultimate equal this value, P ultimate divided by area of footing. From the previous step, you selected your dimension of footing, maybe B and B if it's square, or B times L if it's rectangular. So area of footing, B times B or B times L. I can get the Q ultimate, which is the factored soil pressure. I will come here at the edge or the face of your column. At this face of the column, I will get a section and calculate what is the M ultimate at this section. So I will assume fix it here and this part as a beam. So we have a beam and fix it, and we have pressure coming from the soil to the footing. This load equal Q ultimate, and this length equal LM. Your LM is the distance from the face of your column to the edge of the footing. Do you know how can I get it? For this one, for example, here is the column B times C. What is this distance?
B minus X?
No.
No.
No. Forget X, I don't have any distance X.
Sorry.
I need to figure out. B is the total distance. If you divide B by 2, I will get distance from here to here. If you divide this dimension of column by 2, I can get this dimension. So if you subtract this total distance, B divide 2, minus your column dimension by 2, I can get this distance. That's right. So LM equal B divide 2 minus your column dimension C divide 2. I can get the distance of footing after the face of the column. So right now I have load Q ultimate, which is pressure, and I know what is the length for this cantilever, and I assume this cantilever is fixed at the face of your column. I can get my moment M ultimate equal Q ultimate time LM square divide 2.
Oh, that's from the.
Structure analysis.
Yes.
If we go back to structure analysis, if you remember, if you have cantilever with uniform distributed load W and your length L, your moment here equal W time L square divide 2. And if you would like to know how can I get this equation, that's right. Anybody know what is the equivalent to load for this distributed? W times L. What this distance is? L divide 2. If you are taking a moment here, we have force time distance. We have WL. Time your distance L divide 2, your bending moment will be WL square divide 2. So your bending moment, W, L square divide 2. Your W here is the ultimate pressure from the soil on the footing. And L is the distance after the face of the column. And you can get it from this equation. Your bending moment equal W L square divide 2, but we need to multiply this one by L, this distance. Actually, we have two options. You can neglect this L, or you can keep it. If you neglect it, your bending moment for unit width, which is 1 feet, and your steel reinforcement for each 1 feet. I recommend this anyway. But if you multiply by the total width of your footing, that means your moment for total moment, and your steel reinforcement for total width.
What are we checking for there? Are we looking for something to be in between certain numbers?
I'm looking for the idea here, your concentrated load will be converted to pressure by this area of footing. This pressure will react to your footing and cause bending moment. Your bending moment will be converted to steel reinforcement. So right now, I'm looking for what is the value of bending moment that this pressure from soil will apply on this footing. Once you get your bending moment, M ultimate, go ahead and get this value. Rn equal M ultimate divide phi B D square, and go ahead and get your rho required. Anybody remember what is the meaning of rho?
The area.
Area of steel
Area of
divided by B time depth of the footing. So I know what is the width of footing, depth of footing. I now calculated what is the rho required. I can figure out what is the area steel. And remember, we have minimum reinforcement. This value must equal or exceed this value or this value based on what is the grade of your steel reinforcement. Also keep in your mind the maximum spacing between bars in footing is 18 inch. So your footing, once you determine how many bars, please go ahead and determine what is the spacing between two bars. This spacing must be 18 inch or less. we will see all of these steps during our exam. Once you are done with your design, because right now I can answer what is the total thickness, what is the dimension, how much is steel reinforcement, I need to do more to check. The first one thing called two-way shear, we can call it bunch, the best description, check of bunch. And the second one-way shear, it's very easy, nothing, just steps. Okay, let's start our first example and see what's going on. We need to design an isolated footing for reinforced concrete column of size 15 times 15. Wow. We have a column B and C. Your B equal 15 inch, your C equal 15 inch. So that means before starting this example, I have to solve another example how to design your column, and we are done with this example. Carries a vertical load of 150. 150 kips. The same bearing capacity of soil. So we have a mistake here. Vertical load 150. Your dead load equal 50 kip, and your life load equal 100 kip. I'm sorry. We need to determine which reaction for dead and which reaction for life. Bearing capacity of your soil, so dead load equal 50, life load equal 100 kip, and bearing capacity, which is Q allowable, how much? 4,000 pound per square feet. FC prime equal 4,000 PSI. F yield equal 60,000 PSI. Okay, let's start step by step. What was the first step? B, which is surface reaction on the column without any factor, equal 50 dead load plus 100 life load equal 100 kip. Second step, what is the ultimate load? B ultimate, which is factored load. Go ahead and multiply your dead load by 1.2 and your life load by 1.6. What's your reaction? 1.2 times 50 plus 1.6 times 100. 220. Okay. Perfect. Third step, I'm looking for thickness. Your total thickness of your footing, HF, equal depth plus 4 inch. Okay, what is the value of depth? Go ahead and determine. You have a round column or rectangular column?
Rectangular.
I think rectangular or square. I mean not circle. So your depth will be 4 d square plus 2 b plus c, b plus c, 15 plus 15. Time depth equal P ultimate divided by phi mu c. B plus C, dimension of the core. And we need to figure out what is the value of B ultimate. B ultimate equal 220. Keep, be careful about your unit. Phi equal 0.75. I'm still looking for mu C. Mu C equal 4 times lambda equal 1 for normal concrete, square root of FC prime 4000. Your value, we have a mistake here, be careful. 4 times square root of 4000. 4 times square root 4000. 252.98. So I will put this number here, 252.98. Do you know what is the mistake here?
The unit?
Yeah, your P ultimate in Kip, but you are using here your FC prime in pound per square inch. So Kip and pound, we need to convert one to the other one. So what do you think? I will multiply this one by 1000. Or you can use this one 4.
Dr. Heyman, I made a mistake like that on the homework, where I did the square root of 4, and like, you know, with the unit stuff, it wasn't equal. Like, the square root of 4 times 1000 does not equal the square root of 4000.
Okay, okay. The best way to solve this one, because these equations are empirical equations. So if you need to follow the actual unit, it's not easy. So the best scenario, this P ultimate should be in pound and everything in pound. I cannot follow the unit because your numerator P ultimate, your denominator square root. So if you put your pound by square root, this one will be pound, so your unit does not match. So keep everything in pound. This is the best way. So your value will be 4d squared plus 60d equal how much? 220 times 1000 divide 252.98 86963. Solve 4d squared plus 60d